Okay, next up we're going to prove the derivatives of the hyperbolic functions. And so first up we have the hyperbolic function for cos. And what that is going to be is e to the power of x plus e to the power of minus x. Let me just make sure I got that right. Over 2. So first, we'll be using a couple of the derivative rules. So we know that d over dx of a multiplied by f of x is the same thing as a multiplied by simply the derivative of f of x, because the constant a has no effect. And so we're going to use that to pull out the 1 over 2. That's how we're going to deal with that. And then lastly, the derivative of f of x plus g of x is equal to the derivative if you took them separately. And so, how we're going to apply this to this is to separate the e to the power of x and the e to the power of negative x. And those are two derivatives that we can easily find instead. And so this means that d over dx of e to the x plus e to the minus x over 2 is going to be equal to 1 over 2 into the derivative of e to the x plus e to the minus x. And then we're going to separate them into d over dx e to the x plus the derivative of e to the minus x. And then next up, we're going to apply this derivative. Is quite easy to find. We know the derivative of e to the x is e to the x. And this one, we're going to use a chain rule to make it as easy to find as the other one, where we know dy over dx is equal to dy over du into du over dx. So if u is equal to negative x, then that means the derivative of e to the power of u over x is going to be dy over du, so that's e to the u, multiplied by the derivative of this with respect to x, and that's just going to be negative 1. So it becomes negative e, and then you're just going to put in the u, so to the negative x. And so what this will now become is that the derivative of this is equal to 1 over 2 into e to the x minus e to the minus x. And if we rewrite all of that, that becomes e to the x minus e to the minus x over 2. And this is also another hyperbolic function of sine. And that's your final answer for that one. Next up, we are looking for d over dx of the hyperbolic function for tan. And we know that this is equal to the hyperbolic function of sine over the hyperbolic function of cos. So what we're going to do here is we're going to use the quotient rule. So let's just quickly write down what that is. Okay, and so in our question, we have that f of x is equal to that, and g of x is equal to this. We already determined the derivative of this, and that is going to be that. And in similar fashion, if you go through the same process, but instead with the hyperbolic function for sine, you are going to get that the derivative is actually the hyperbolic function for cos. And so now when we plug all of that into our formula here, it will become into minus into And this is all going to be over that. And so this will become squared plus, sorry, this is minus. And we actually have an identity here too, where we know that sorry, just one moment. Here it is. Is equal to 1, and so we're just going to put that in here, and it will become 1 over that, and this is actually equal to that, similar to how secant is 1 over cos. So the hyperbolic function for secant is 1 over the hyperbolic function for cos, and that is going to be our final answer for that one. Next up, we are looking for this. So as I said, that this is equal to 1 over the hyperbolic function for cos. And so again, we're going to apply the quotient rule. We have f of x is equal to 1. The derivative is going to be equal to 0. G of x is equal to the hyperbolic function for cos of x. And we found that the derivative of that is, of course, the hyperbolic function for sine of x. And so we're just going to plug that all into our formula for the quotient rule, and that will become 0 into that minus 1 into that. And that is all going to be over this squared. So that'll become negative. And this can be rewritten in a form that is a bit more familiar to us. And of course, this is equal to the negative hyperbolic function for tan multiplied by the hyperbolic function for secant. And that's going to be our final answer for that one.